Okay, so when we're talking about the slope, we're talking about a line on a coordinate plane. We're talking about graphs, okay? And basically what they're asking you when they're talking about slope is what is the rate of change? And in order to solve that, we need to put the vertical change, so how much it changed up and down, over the horizontal change, so how much it changed from side to side. And we call that rise over run. How much did it rise, up or down, over run? Question?
Is this gonna be like we did like in last chapter we drew something, it stopped, kept going?
Nope. Okay? They also, on this front page, give us an example of a positive slope, which is a line that goes from left to right. It points up. Okay, so you still have a coordinate graph, an X and a Y, but the line, if it goes to the right, pointing up, it is a positive slope. So this is an example of a positive slope. Yes?
Are we going to be graphing too? Like, are we learning how to graph?
Not today, but you will.
Okay.
Okay, and then the reverse is true, going from left to right. If it goes down from left to right, it's a negative slope. Okay, in your book, on page 118, let's look at the first example. Okay, so look in your books. Look in your books. If it's not open, open it. The graph is already there. They've given you 2 points.
Can you draw this?
If it's going to be helpful to you, you may. 1 point A is at 2, 1, and B is at 5, negative 3. So the first one, over 2, up 1, here is A. And then the second one, can you guys see that okay? Do I need to move? Is B, and that's 5, negative 3. So I'm going to go over 5. So 1, 2, 3, 4, 5. And then down to negative 3. So B is here. Question?
Well, I was going to say, will it be a negative slope?
Yes. That's an excellent notice right off the bat. It's pointing to the bottom right, so it's going to be a negative slope.
Write that.
Sure.
So if it points to the bottom right
Yeah.
and starts from the,
And they're all going to start from the left, but if as you move it goes down, it's negative, and if as you move it goes up, it's positive. Okay, so for this one, if our question, it says find slope. Okay? When we have a graph, it's actually easy. Because all we have to do is check our change, okay? So remember, we have the rise over the run. The rise is the up and down change, and the run is the side to side. So if I start on the left point, whichever one comes first, that would be A in this example. And if I'm checking the rise, the up or down movement, I go down to get to B. Does everybody see that? So I'm going to dot that line so that I know that that was one I made after. And if I'm counting my graph points, graph paper is helpful, and I know that you may not have it. 1, 2, 3, 4. I went down 4. So I'm going to show that as -4 because I went down. And then to get to point B, I have to go, now I'm doing my run, my change going side to side. I have to go over 1, 2, 3. It's positive. So you're always going to make a triangle. You're always going to make a triangle to find the slope. That dotted line is your triangle. Question?
How are you supposed to know the spaces without graph paper?
So I'm going to give you a coordinate plane for your homework. So, but in your notes, that might be a little tricky, right? You'd have to draw it really well. Any questions on this one? Make sense? Let's do one more. The quick check underneath. Find the slope of each line. Let's take a look at it. So we're going to start on the left and move right. Let's look at the first one, A. Do you see that near the middle of your books on page 118? So A is at -3, 2. Can you put without maybe flip your pencil over so that you're not writing in your book? Put your pencil on that point. The first one, which is towards the bottom, right? Now count. So we have to go up or down first to make our triangle. How many spaces are we going to go and which direction to get to 2, 4? Logan?
Would it be 4?
Grace?
2 up and 5 down.
Good. So we're going up 2, and we're going side to side 5. So our slope is 2/5. Slope can be improper. So the 4/3 that we got earlier is an acceptable answer. We do not have to change that to 1 1/3. Okay, let's take a look at B. For B, if we start at the left point, we have a starting point of -2, 2. Where are we going to go? How many points, up or down, and how many points to get to our second point at 2, 0? Delaney?
It would be -2,
Great.
and then
So we're going to go down, so -2,
and then 4.
and then over 4. Now this we can reduce to -1/2. So let's write ourselves a note. In our notes, always reduce slope, never simplify. What's the difference between the two? What's the difference? Don't they mean the same thing? When do we use simplify?
One is converting or
What's that word?
mixed number.
Right, we don't want a mixed number. So we're going to leave it improper.
How did that person about 2/5?
Which one? Sorry?
2/5.
This one. Okay. In your books, that was A. Are you putting your finger or your pencil on -3, 2? That's the first point on the left, okay? So then from there, how many spaces do we have to go up to get to the next point?
2.
2. And then from there, how many spaces over to get to 2, 4?
5.
So that's how we get 2/5. Does that make sense? So from here, we went here, we're going to make our triangle this way. So we went up 2 to get to the this line, and then 1, 2, 3, 4, 5. So you're just counting the spaces.
And how do you get the negative one?
So that one came from